So in this lesson, we're going to talk about Slurm, scheduling jobs, and submitting jobs. So by way of introduction, I'm going to go over the two main types of Slurm commands: the informational commands that get you information about the cluster and the state of the queue, and the job interaction commands, how to submit jobs and cancel jobs, things like that. I'm going to talk a little bit about scheduling, what scheduling is, how priority might work, and the backfill algorithm, which I'm doing hopefully to encourage people to really not just use the default time limit on things. And then finally, I'm going to show you how to submit jobs and get some useful information out of certain commands, as well as the commands to actually submit a job. So the three informational commands that I wanted to talk about are the sinfo command. This one gives you information about nodes and partitions. So it'll give you information about the state of the partitions, which ones are available, which ones might be down, and also which nodes are currently allocated, which ones might be down, drained, or idle. It'll also give you the partition time limits by default. There's the saccount, SACCT command. This one gives you information about jobs. So you can run this command and give it a job ID, and then you can have it output information about like how much time elapsed since when the job started, when the job actually started, when it ended, and you can also give it some information to like narrow down. I just want the jobs between, this day and this day. It's a very powerful tool to look at your kind of historical information. And then finally, the SQ command. So the SQ will show you the current job queue, what jobs are currently running and which ones are currently scheduled. You can also sort this by user and partition. And this is just a good way of seeing like what's going on in the queue, maybe give you an idea of how long your job might take to launch and kind of see what's going on the system. So let me show you a few demos of these commands. Let's run through some examples of these informational commands. To start off with, we'll do the sinfo command, which gives information about all the partitions and nodes. So this will list off each of the partitions and what state all the nodes are in that make up each of these partitions. The other important thing is going to be the time limit, which is the maximum amount of time that a job can run in one of these partitions. The next command is the SACCT, saccount command. This gives information about your jobs that you've run in the last 24 hours. You can also pass it a flag for when to start. So if I wanted to look at all the jobs I've run since April 2nd, 2025, you could pass it the -S flag and can check that and see additional jobs. There's also the -O flag, which allows you to pick what fields you want to see. So I could do like something like this: -O, elapsed, start, end, and node list. And this gives me the information of what nodes my jobs ran on, what the job ID is, how long the job ran, and the start and end of it. The last informational command that I wanted to show was the SQ command. This gives the state of the queue. It lists what jobs are currently running and what jobs are currently pending. So I'll say PD for pending. So we have 2 pending jobs here. Anything with an R is running. If you only care about your own jobs, you do SQ-U, and then you can like put in your own username, and it'll show the state of the jobs that you currently have in the queue. Okay, let's talk about SBatch directives. These are the arguments that you pass to your job script or your job script command, submission command, to tell it how you want it to allocate resources. Checking the SBatch documentation on Slurm's website is really useful. It has all the flags and all the info. But these are the ones that I think are important. So the first one is the partition. This is where you want to actually place your job. Lots of HPC centers divvy up their compute resources into different partitions, some by like CPU type, others by like how long you're allowed to run in it. So setting this and not just using the default is really important, because sometimes the default isn't where your job should actually run. And some centers will actually like cancel your job if it's not running in the right place. The next one is the end tasks, or the number of tasks you want to Slurm to give your job to allocate for it. Each end task is kind of analogous to a core or a CPU. You can also set the tasks per node. And then so the end tasks divided by the tasks per node is the number of nodes you get. So you might want this number not to just be the total number of cores that are available on a single node. Like, say you have a process where you are only able to parallelize it into like 12 different threads. So you might only want 12 tasks per node. Um, Time is how long you want your job to run. Setting this as close to exact of your runtime is very valuable. So what will happen is if your job finishes early, it won't keep the node like allocated to your job and not do anything. Your job will finish. But the reason setting in a time that's like lower than the maximum allowed time is useful is the job scheduler can then use that information to kind of slot your job into like a hole in between two jobs. Like if it can find that your job only takes 30 minutes, it might find a node that's only available for like 35 minutes and be able to slot your 30-minute job into there. Output is the output file for what's being written out to the terminal. And then finally, nodes. Instead of specifying like your end tasks and tasks per node, you can say, I just want 10 nodes. I prefer using the end tasks per node methodology because it tells you, exactly what you're going to get. Whereas if you say, I want 3 nodes, and then you're operating on a cluster that has multiple CPU types, you might get like nodes with 3 different numbers of CPUs. So it's just, I find it better to be a little bit more exact. Finally, the SBatch directives have some mail options available. So you can say, oh, email me when the job starts, if it ends, if it fails, etc. And then also, you can set the email for where you want it to email to. So I've mentioned scheduling. So there are multiple ways to schedule jobs. The naive way is first in, first out. People submit a job, and the first job in is the first job to run. Most centers use what's called multi-factor, where it takes in a whole bunch of information, such as like partitions might have certain priorities associated with it, quality of services, how long a job's been waiting into a queue, and then a thing called the fair share, where like groups are assigned a certain number of shares on the system, and the more you use, you get this ratio of how much of your share of the resources you've used. All of these are kind of put into an algorithm, and it spits out a priority, and that's how it might schedule jobs. You get this priority based on multiple factors. And so at a lot of centers, the fair share, if they're not using like strict allocations, fair share can be very important. If you like run a whole lot of jobs, the system might start saying that you've been using more than your fair share of the resources and bump your priority down. Most centers also use backfill algorithms, and as I mentioned, setting the time is really crucial for this. The more information that the job scheduler has, the more efficient it can schedule jobs. The actual commands for submitting jobs or manipulating jobs, the big 4 useful ones are salloc. So this obtains a Slurm job allocation. So this is a way to ask Slurm for resources, and then once they're available, it will give it back to you. And from there, you can run like MPI and srun commands to run on the compute nodes. SBatch is probably the most useful. So, you have a giant queue of jobs. You don't want to be sitting there, monitoring the queue, submitting your job, and then waiting for your job to pop up and be able to, run it or something. You don't want to have to like leave your terminal open. SBatch allows you to write a batch script, usually in like Bash, to set up your allocation. So you say, I need this many nodes, I need this many tasks. I'm going to load these modules, and this is the program or the program going to run with these arguments. And you use sbatch, submit that script. The job scheduler will ingest that, and then when it allocates the resources, when it has it available, it'll just run through your script. srun is the next one. It can be used to run a parallel job. You can use it in place of MPI run, MPI exec. You can pass arguments to it that are equivalent to the sbatch directives, and you can use this to run like interactive jobs or run a command on the compute nodes if the queue say is clear, and you can see it immediately. Cancel job ID will cancel the job. This can be useful if you know that your program isn't actually doing what you want or it gets stuck. You can cancel it. And so now let's go through some of these examples. So let's talk about some of these commands that deal with managing and submitting jobs. The first one we're going to talk about is the salloc command, which will allocate your resources on the compute nodes, but keep you logged into the login node. We don't really recommend using this command. It's only really useful if you need to debug your MPI run, MPI exec, or srun commands. To start off with, I'm going to run printf and grep for Slurm in all caps, just to show I don't have any environment variables set here. Then I'm going to use the salloc command, and then you have to give it a partition. We're going to use the debug partition. The number of tasks, this is the number of cores that you're assigned by Slurm. And then the tasks per node, which is how many you want per node. Your end tasks divided by your tasks per node will get you the number of nodes you end up with. And I hit enter, and it says I'm granted an allocation, and node 0 is ready for job. If I do printf grep slurm, we'll see that I have like a submit directory. I have a bunch of Slurm environment variables. And if I run hostname, it's going to say I'm still on Chinook 04. So I am going to now run mpi run-np slurm ntasks hostname. So this is going to run the hostname command on all the cores and CPUs that I have allocated to myself. Oh, and I need to actually load the FOSS 2022A module before I do that. Now I'm going to run the mpi run np slurm ntasks hostname. And we'll see that it just prints out n0.cluster 24 times, one for each of my tasks. You can also, instead of using MPI run, you can actually use the srun command as well, and it will do the same thing. The L just gives a task number as well. So when you use salloc, MPI run and srun will do basically the same thing. Let me run a quick clear command to clear out my terminal. All right, let's go to some examples. So I have a bunch of files here called something.slurm. These are all just bash scripts. The ending extension doesn't matter. I just typically use Slurm, so when I'm looking over my work in like a month or two, I know that these are submit scripts. We're going to take a look at this example.slurm. So as I mentioned, this is just a bash script, so the ampersand, number sign, hashtag, whatever you want to call it, is a comment unless it's immediately followed by the sbatch in all caps. If you have that number sign sbatch, that turns it into what's called an sbatch directive. And these are the arguments that you're passing to srun to salloc. So you can pass it things like a job name, what partition you want to use, your end tasks, tasks per node, how long you want the job to run. And then you can also set up mailing, like do you want the scheduler to email you when the job starts, when it ends, if it fails, and what the email address is. You can also set what file you want the output to go into. So this is the output that would show up in your terminal if you were running things. It's not like any output files that your code generates that you save. And then you can pass it a couple special variables. The percent lowercase j is the job ID, and the percent lowercase u is the user. And then in it, you just do the same things that you would do if you were at the keyboard. You'd load some modules. I put in a little bit of time, a little bit of code to calculate the time. And then I'm just going to be running host name on it. And then to submit this, you do sbatch, the name of your script. So in this case, example.slurm. It'll say it submitted the job. I'll do an sq-u, and I'll probably already finished. So if I do an ls, we can cat this file, and we'll see that it did the exact same thing as running it with srun and salloc. You can also run the saccount command that we covered in a previous example on this ID. So we'll do this like 339268, which will also give us some extended information about that. Now I want to talk a little bit about how jobs are scheduled as well with the backfill algorithm specifically. So I have a couple other jobs here. We'll have long job, which is just an hour-long job. So let's submit this job right now, sbatch long job. Then I'm going to sbatch a 2-node job. So if I do sq and look at what jobs I have this longer job is currently running. It has it had resources available. This 2-node job is waiting because it needs 2 nodes, and there's only 2 nodes total in the debug partition, so it needs to wait for the other job to finish. And then I'm going to run long job again, and then a short job. And then I'm going to do sq to look at what's going on. So all these things are currently waiting. They're trying to get some resources figured out. So the long job needs to wait for the 2-node job to finish up. And the short job is currently waiting to be prioritized. So what's going to happen though is in a few moments it's going to be backfilled in. Because this short job can finish in the time, finish before the long job finishes, it can slot this in before, as you can see it's running right now, it can slot this in before the 2-node job. And so that's one of the important reasons why you always want to fill out the time variable, the time sbatch directive. It helps jobs get scheduled more efficiently, and it might be able to find like holes in the queue where it can put in a smaller job. And the more exact you get that, the more efficient the scheduler is.